Yeah.
Let's look at it. Just a minute, beta. Can you see my screen, please?
Yeah, I can.
So I was asking you, in which case the force of attraction between the particles of matter is the maximum. You said
I said solid.
solid, and minimum in
Gases.
gases. Fine. I'm giving you an example of solid. Let's take example of ice. Ice is made up of particles of matter, water, right?
Yeah.
When the particles of similar substances attract each other,
Yeah.
the forces are cohesive forces.
Yeah.
In case of ice, there are many water molecules. They are attracting each other with a strong force of attraction. So the force of attraction between the particles of water over there is cohesive force. When the like atoms, they are attracted, that is called as just receive the message that you're not joining.
I'm here.
So here, actually you joined 20 minutes later, so I'm receiving the message just now.
Okay.
Just a minute, I'm just trying to see. Yes. So I was telling you, adhesion and cohesion. When the forces of attraction are between like molecules, like same, that is cohesion.
Yeah.
But when the forces of attraction are between two different types of molecules, for example, I'm sticking two different one paper on the surface of a wood. I'm applied adhesive on the surface of a paper and stick onto the wood. So now the particle of wood and the particle of paper are sticking onto each other. That is adhesion.
Yeah.
Understood? The force of attraction between two different particles is called as adhesion. The force of attraction between two same particles is called as cohesion.
Okay.
You understood?
Yeah.
Now I'm asking you a question. In the morning, when there are water droplets on the surface of the leaves, you know, when the dew happens, dew is formed. So what type of force is present between the surface of the leaf and the water droplets?
Wait, can you repeat that?
In the morning, when
Yeah.
water droplets are formed on the surface of the leaf, when we get up in the morning, sometimes water droplets are found on the surface of the leaf.
Yeah.
So what type of force is that?
Adhesion.
Yeah, tell me what adhesion.
Yeah.
Yes, adhesion. Fine. Now, the particles of gases, what force of exist? Let's say in the atmosphere, oxygen gas is there. The oxygen gas is revolving in the atmosphere. What type of forces can say existing between the particles of oxygen gas?
Cohesion.
Sorry, Ayan?
Because they're sticking together.
I can't hear you clearly.
Cohesion, because they are sticking.
Cohesion, yes. So now your difference for adhesion and cohesion is clear.
Yeah.
Okay, got it. We discussed about definition of matter. We discussed about the state of matter. That's what they're telling you over here. So to begin chemistry, it is important to understand that matter is of three types basically: elements, compounds, and mixtures. You know this?
Yeah.
Okay. Now tell me the difference between elements, compounds, and mixtures.
An element is the same, is two or more of the same type of atom together chemically bonded. An atom is like the fundamental unit
Atom,
of.
I'm not talking about atom. Elements, compounds, mixtures.
Compounds are two or more elements of different atoms chemically bonded.
Okay. Is there any specific formula for them or no?
Huh?
Is there any specific formula for the compounds?
I'm not sure.
Yes, it is. Compounds are the ones which are having a specific formula, beta. We say sodium chloride, NaCl. It's having a specific formula, so it's a compound.
And then elements
And
are.
just switch on your camera. Switch on your camera. It would be comfortable for me. Take the class then.
Okay.
Yes. Yeah. So compounds are the ones which are having a fixed formula beta. Means the atoms are combining in a fixed ratio over there.
Okay.
Okay. What about mixtures? What do you think about mixtures?
Isn't that when the substances are like mixed physically, but they can be separated?
Yes, and they don't have a fixed formula actually.
Yeah.
Because there's no particular ratio for them. Understood? Okay. Can you give me an example of element and compound and mixture? All the three of them example for
Sodium chloride is compound.
okay.
Hydrogen is
Apart from sodium chloride, because I gave that to you. Another example.
hydrogen peroxide.
Done. Extra?
Yeah, that's a compound.
What's the formula?
H2O.
H2O is water.
Oh, not sure. I just know it.
H2O is water. H2O2 is hydrogen peroxide.
H2O2.
Yes, it's hydrogen peroxide. Perfect. It's a compound. Done. Give me an example of an element.
Hydrogen, oxygen.
Perfect. Mixture.
I don't know.
Which are mixture? Air. Air is a mixture of gases.
Oh, you can separate it, or like like salt and water.
Yes. Sugar and water.
Yeah, sugar, water, salt, and water. They can be separated like by evaporation.
Any mixture example you can give, beta.
Yeah.
I hope these terms are clear to you. Elements. So whenever Ayan, you are mentioning about compounds now, see read the definition over here. I have shared my screen with you. Please read the definitions. Elements, compounds, and mixtures.
Elements are the simplest substances made of atoms that cannot be broken down. Compounds are substances made up of two or more atoms chemically bonded in fixed ratios and have different properties than their components. Mixtures are substances made of more than one element or compound, not chemically bonded together, so they can retain their individual properties. There are two types of mixtures: homogeneous and heterogeneous.
Okay. Understood?
Yeah.
Fine. Now, mixtures are of two types they're telling you. Homogeneous and heterogeneous. Do you know the meaning of these?
No, but on the screen it says that they're uniformly distributed for homogeneous, and heterogeneous they're not the components are not uniformly distributed. Does that mean like
What I mean by this, Ayan? Wait. I have sugar and water. I took sugar, I took water in a glass and added 2 teaspoons full of sugar and I stirred it with a stirrer. Within few minutes, all the sugar will be dissolved in water, right?
Yeah.
Okay. Now, when the sugar gets dissolved in water, can you see water and sugar separately or they appear as one solution only?
They appear as one.
So that's a homogeneous mixture where you can't differentiate what things you have mixed.
So it's like not they're still there, but like you can't make it out.
You can't make it out what you mixed.
Yeah.
Now you take sand and sugar particles and you mix them. After mixing them also you'll be able to make out this is sand, this is sugar. Yes or no?
Yeah. Yeah.
Is this that is heterogeneous mixture means after mixing them also you can make out what two things you have mixed.
Yeah.
Now you understood?
Yeah. Homogeneous you can't make out, heterogeneous you can make out.
Yes. Now tell me air. What type of mixture is air?
Isn't air composed of water as well?
I'm talking about normal air, not the polluted air, the one which is containing dust and smoke. So you can see the dust particles. No, it's normal air. You think what type of mixture it is?
Homogeneous.
Yes.
Because it has oxygen and water, right?
No. Beta, the air around us is nitrogen, oxygen, carbon dioxide gases, no?
Yeah, I said that. Oxygen,
Not water, it's not water actually. If it is present, it is water vapor, not water.
Okay. I thought it was
Don't say water, you say water vapor.
just like the what you call the gas form of water.